To our lesson on slopes of parallel and perpendicular lines. Your learning targets for this lesson are to be able to identify and write equations of lines that are parallel or perpendicular to a given line. So let's start off with just defining what we mean by parallel and perpendicular lines. Parallel lines are lines that are in the same plane, but they don't intersect. They have the same slope, the same slant, but they have different y-intercepts. And here's a picture over on the right-hand side of two lines that are parallel. You can see that they cross the y-axis at different points, and they will never intersect. Perpendicular lines are lines that intersect at right angles. There's a picture over here on the right-hand side. Their slopes are opposite reciprocals of each other. And what we mean by that is you flip whatever the slope is upside down and change the sign. So it's an opposite sign and the number is the reciprocal. So using those definitions, let's go ahead and practice some problems. Our first problem says to determine if the equations represent lines that are parallel, perpendicular, or neither. So let's go ahead and start some of these problems. So the equation on the right, it's very easy to see that the slope is -2/5, okay? If this is in slope-intercept form, there's the slope. So the one on the left-hand side, we need to solve it for y, or put it in slope-intercept form to figure out what the slope of this line is. So what I'll do, I'll go ahead and subtract 2x from both sides, and I'll rewrite that. We get -5y is equal to -2x plus 10. Okay, then let's go ahead and divide everything by -5 so that we can get y alone. So our -5's will cancel and we get y is equal to +2/5 x minus 2. So in this equation, we have a slope of +2/5. And this one we have a slope of -2/5. Well, they are opposites, but they are not reciprocals. So this one is a neither. Number 2 says to write an equation in slope-intercept form for the line that passes through the point 2, -4 and is parallel to a line with this equation. So the one thing I want to highlight here is that we are looking for a parallel line. In the next problem, we will be looking for a perpendicular line. So let's go ahead and look at what we need to solve this. Okay, so we want to write it in slope-intercept form. Remember, slope-intercept form is y equals mx plus b. That's the form that we want. We know it goes through this point. We have an x-coordinate and a y-coordinate. And then we also have the slope is -3 because it's going to be parallel, so it has the same slope. So we can substitute in for x, y, and m and solve for b. We already know our equation will be y equals -3x, but we don't know what b is. We need to calculate that. So if we go ahead and substitute for y, the value -4, m is -3, x is 2, and we're looking for b. So this is y equals mx plus b. Well, when we simplify this, we get -4 equals -6 plus b. And then adding 6 to both sides, we end up with b equal to +2. So up here, we can finish our equation. We have y equals mx and then plus b. So that is the complete equation of the line that goes through the point 2, -4, parallel to the opposite line. All right, number 3, write an equation in slope-intercept form. Again, this is going to be in y equals mx plus b form. That's slope-intercept. Passes through the point and is perpendicular to the line. Well, this one has a slope of -3. In order to be perpendicular, we want the perpendicular slope. So I'm going to write the slope of the perpendicular. Sometimes that's the symbol we use for perpendiculars, like an upside down T. We want it to be the opposite sign, which is +3, and the reciprocal of 3 is 1/3. So that's what our slope will be. So again, we can write the beginning of our equation, y equals 1/3 x, but we need to figure out what b is. To do that, we use our slope-intercept form. Y is negative 4 is equal to m, which is negative, oh, excuse me, is 1/3, excuse me for that. Y equals m times x is 2, plus b. Okay? So this time when we multiply, we get negative 4 equals 2/3 plus b. Now this one's a little more complicated. We have to subtract 2/3 from both sides. And when we do that, we end up with b equals negative 4 2/3. So you could write that as 14/3, however you want to write that. I'll just leave it as negative 4 2/3. And then this is the equation of the line that is perpendicular to this line. Okay, these are perpendicular to each other, and it goes through this point. Number 4 says, determine if the lines passing through the given points are parallel, perpendicular, or neither. So we have line 1 goes through these 2 points, line 2 goes through these 2 points. So we need to figure out the slope of each line. And remember, the slope is y2 minus y1 divided by x2 minus x1. So we're going to say 5 minus 1 for our y coordinates divided by 3 minus 2. That gives us 4 over 1, which is 4. The second one here, the slope of this line is 2 minus 6. Whoops, I messed that up. Hang on. Fortunately, I realized that before I finished. So this one will be 2 minus 3. How about that? The y minus y divided by 2 minus 6. That gives us a negative 1 over negative 4, which is a positive 1/4. So again, slope 1, slope 2. They're reciprocals, but they're not opposite reciprocals. This is a neither. Okay? Number 5 says, write an equation in slope-intercept form again for the line that passes through the point, perpendicular again. So pay attention to what we're looking for. It's perpendicular to the line with the given equation. So this one has a slope of 1/6. If it's perpendicular, the perpendicular slope must be the opposite, which is negative, and the reciprocal is 6. So we're going to have y equals negative 6x plus or minus something. We have to figure out what b is. And so let's do that over here on the left-hand side. So y is 2. Remember, I'm getting that right here. This is the y coordinate. Here's the x coordinate. 2 is equal to m is negative 6, x is 1 plus b. So we want to multiply these two. We get 2 equals negative 6 plus b. Adding 6 to both sides to get b alone, we end up with 8 is equal to b. So we can say plus 8. So that is the equation of the line perpendicular to the given line going through the given point. And our last problem for this lesson says, use the slopes of the segments to show that ABC is a right triangle. Well, here we have triangle ABC. If it's a right triangle, it must have a right angle. So we are going to check to see if segment AB is perpendicular to segment BC. So here's how we would write that. Is segment AB perpendicular to segment BC? That's the question. And it is perpendicular if the slopes of the line, we would need to show that segment AB would be perpendicular to segment BC. So we need to find the slope of segment AB, and we need to find the slope of segment BC using our slope formula. So here we go. The slope of segment AB. So we're going to take 3 minus 1. I'm taking the y coordinates right here. 3 minus 1. And we will divide that by 0 minus a minus 5. So 3 minus 1 is 2. 0 minus a minus 5 is a positive 5. So our slope of AB is 2/5. So we can go ahead and write that above that side there. So the slope of this line is 2 over 5. So if these are going to be perpendicular lines, then hopefully we get negative 5/2 on the other side. So the slope of BC, we'll write that one is 3 minus a minus 2 divided by 0 minus 2. Well, 3 minus a minus 2 is 3 plus 2, which is 5, and 0 minus 2 is negative 2. So now if you look at these two slopes, this slope is negative 5 over 2. They are opposite signs and they are reciprocals. So therefore, yes, it is a right triangle. Triangle ABC is a right triangle. And there you have it. We'll see you in class.